Thank you very much for that introduction, and thank you very much for having me tonight. I am going to be talking about JSON Web Tokens and a modern authentication flow, which is going to be a token-based authentication flow. And I know that the title mentions single-page applications, but this is a Node.js meetup, so I'm not going to be talking about React or Angular or any of those cool JavaScript frameworks, but we're going to keep it a bit more back-end focused and talk about authentication flows and the things that happen behind the scenes. But let me quickly introduce myself. So as introduced, my name is Bellen, and I'm a developer advocate engineer at Auth0, which means that I'm a developer and I like to talk with these developers and connect with developers. And we slammed engineer a bit behind it just to let you know that I can also write some code as well. I'm a Google developer expert, and you can find me at Sambigo on most of the social media networks out there. What we're going to be talking about today, first we're going to see a little bit of what I consider traditional authentication. Then we're going to transition to what a token really is and see a bit more about JSON Web Tokens. And lastly, we're going to see token-based authentication and a modern example of a token-based authentication flow. So let's get started with what I consider a traditional authentication flow. And this is a flow where you usually have your server generated pages. This might be in ASP, it might be in PHP, in Python, and Java. It doesn't really matter. This flow is usually the same for most of the people. And if you've been around on the internet for a while, this is something you've seen a lot and you still see today. And in this scenario, you have a user who goes to the browser to visit a web page, and the browser is going to request a page to a server. But if the user wants to access a protected page, the server is going to say, hey, you cannot access this page. Could the user please log in first? The user is going to enter their credential, username and password usually, which is going to be forwarded by the browser to the server. It's going to check the database and see if the username and password is correct. And if it's correct, the server is going to say, okay, this user is allowed to see this page. I'm going to return that page so the user can see it in the browser. It's a very common scenario. We see this all the time still today. And there's nothing wrong with this. And in order for the user to not have to log in with each request to a protected page or each protected action, usually the server is also going to issue a cookie, which will be saved by the browser. And any subsequent request will be, the cookie will be attached by the browser to the server, so the server can just pass along these protected pages without the user having to authenticate again, because that cookie validates or says that the user has been authenticated before. And when the cookie is okay, we're just going to present the page to the browser. And that's what I call a traditional web app. It's a traditional flow which we see with server-generated pages where all the logic is handled by the backend. This can be a whole service. This can be a whole load of microservices or a whole server park. Doesn't matter. It's usually a backend that does all of the logic and also generates the pages. But if we look at these traditional web apps versus single-page applications, there are certain differences that might make it difficult to do the exact same flow with the modern single-page applications. Where in a traditional architecture, you have a browser, you have an application that goes to a backend. The backend does all the heavy lifting, and usually it's a one-to-one. You have one browser, obviously, and one backend. This might be 10 servers, but it's still one backend. While a single-page architecture might look like this, you could still have one backend, but often we see certain microservices. Maybe all of them have a different domain. You have a main API. You might have an authorization server, which handles all your user or identity data. You might have a payment server, and so forth and so on. And these might be all of your own services, or you might also have to use external services. So often with single-page applications, the single-page application lives in a domain, and you have certain APIs or services in the backend that live in other domains. You also might have something that I call a multi-architecture. I don't know if there's a real name for this, but it's something like this where you have your main API, but you have different consumers of that API. You might have a mobile application, you might have a web application, you might even have a desktop application or a CLI, and they all want to consume that same API. Now, the funny thing is, we saw this example where we set a cookie previously with the traditional web application. But cookies are a thing that are only being used by browsers, by the web. So it would be nice if we could do the same kind of authentication for mobile apps, web applications, desktop apps, CLIs, and so forth. And as a cookie is used by a browser, they cannot really be used by native applications. So what are some of the problems with a traditional cookie-based approach? The first one is cookies do not like cross-origin resource sharing, of course. And if I ask this to you all in the audience today, raise your hand if you like CORS. Nobody will raise their hands because nobody knows how CORS works. I don't know how CORS works. Nobody knows. There's one person on Stack Overflow who knows how it is. So every time we run into a CORS problem, we just type in Google, I have a CORS problem, end up on Stack Overflow, copy the result, and that's it. And cookies don't like CORS. Cookies are issued to a domain, to an origin, and you cannot share them with other origins or other domains. Next up, cookies require state, because most of the times in these cookies, most of the times, not always, they have some kind of session ID, which corresponds to an ID in a database, and that database might contain a bit more information about this session, when it started, when it expired, who it's issued to, and so forth. But in these modern days, we'd like to be as stateless as possible. So if we could get rid of this state in the database and move it somewhere else, that might be nice as well. And cookies on flow. You cannot pass a cookie from one service to another. Your browser might attach it to your first request, to your backend, but your backend cannot keep on passing along these cookies to other services, as they're something that's being used between a browser and a service, and they're issued to an origin. It's not something you can just pass along, which might bring some problems if we have multiple microservices or multiple services working together behind the scenes. For example, your main application is going to do a request to your main API, which is going to do a request to your authorization server, which handles your identity data. You cannot just pass along these cookies from one to the other, not just like that. So what's the solution? Maybe it's token-based authentication. We'll explore that in this presentation. But let's first see what a token is. As mentioned in the introduction, I'm going to be talking about JSON Web Tokens. But first up, to me, a token in general is a unique identifier that represents something. If I can take that token and I can get some meaning out of it, I consider this a token. And there are a lot of different kinds of tokens. We have an access token, and if you've worked with APIs before, judging that this is a Node.js meetup, I think a lot of us have worked with APIs or have built APIs. We might have seen access tokens in the past. They basically give you access to an API or not, depends on who it's issued at or issued to. An ID token tells us a bit more about the identity of somebody that authenticated on a web application. And refresh tokens allow us to refresh our tokens and to get new access tokens if they have expired. So these are three kinds of tokens and three different types of tokens that all do something else. And they're often an opaque string in the form of a UUID, a unique ID, which might correspond to a database ID, and we can get some more information about that token in our database based on that unique ID. But it don't have to be. If you're familiar with the SAML framework, which is a little bit of an older enterprisey authentication framework, SAML tokens are a bunch of XML. XML, I know I said it's a little bit of an older framework, but it's still very much in use, especially in the enterprise world. And they're not an opaque string, they're XML. And of course, you also have JSON Web Tokens, where I want to be going at in this chapter. And at .0, we use JSON Web Tokens as much as possible, just because we think they're powerful and we really like to use them. They're convenient in certain scenarios. So if you've never seen a JSON Web Token before, this is a JSON Web Token. And usually when you see it, it's not in color, so you don't really notice that it's built up out of three parts. But a JSON Web Token, most of the time, 99% of the time, is going to be built up out of three parts. The first part, the middle part, which is usually the biggest part, and the last part. Where the first part here in red, and the three parts are separated by a dot always, but the first part is called the header. And the header is basically a base64 encoded JSON object. And header is going to tell us a bit more about the token itself. It tells us which algorithm we can use to verify the signature, which we'll see in a second. And it tells us what it is, the type. It's a JSON Web Token. So if we take that header, that first part, run it through a base64 decoder, we get this JSON object, which tells us a little bit more information about the token itself. Next up, the second part, the beefiest part, is called the payload. And the payload, again, is a base64 encoded JSON object. Any valid JSON can be put inside of a payload of a JSON Web Token. And this usually gives us a bit more information depending on the purpose of this token. In this case, it's some information that relates to the identity of somebody, which probably means that it came from an ID token, an identity token. So things like the subject, which is a username, the given name, family name, could all be in there together with an issue date and an expiry date. And that's something really interesting. A JSON Web Token can contain its own expiry date. So no need to keep that somewhere stored in a database. We can just look inside of that token, decode the payload, and see when it's issued at and when it will expire. And there's a bunch of claims, and a claim is a key value pair that it's inside of these JSON objects inside of the payload. And the first one are reserved claims. And reserved claims are basically all of the claims that are specified by the JSON Web Token specification. If you go and search for that specification on Google, you'll find a list of these reserved claims. These are things like subject, the user ID most of the time, issuer, which authorization server or which instance, which service has issued this JSON Web Token, the issue date, the expiry date, and a few others are all mentioned in the JSON Web Token spec. The next set of claims are the public claims, which are not necessarily specified by the JSON Web Token spec, but there is the IANA, which also have a list of claims that are often used by JSON Web Tokens. And they maintain this list of often used claims for API interoperability. So you know that if you get a token from, let's say, Google, and if you get a token from, let's say, Auth0, we will always call a family name and not a last name, and a given name might be given name instead of first name. And sometimes this is weird, but if we all stick to this list of public claims that are defined by IANA, we know what to expect from other vendors, other APIs as well. I'll post a link to this IANA list later as well. And lastly, there's private claims. And a private claim is anything that you think is useful information to put inside of that token. As long as it's valid JSON, you can put it in there. This can be a string, this can be a number, this can be a Boolean, this can be an array with strings. Any valid JSON is okay to put in there as a private claim. But a few caveats. First, don't put anything sensitive inside of the payload because it's just a base64 encoded object. Everybody can go to decodebase64.com, put it in there and see what's in there. It's not encrypted, it's just base64 encoded data. Also, keep the payload as small as possible and only put in relevant data because the bigger you're going to make the data inside of the payload, the bigger the token is going to be. And if we use this as, for example, an access token, we're going to send this with each request, which means that we would slow down each request and send irrelevant data with each request in the header of a request. So only keep the bare minimum in there if possible. Then we saw the first part, the header, the second part, the payload. We have to talk about the last part, the third part, which is a signature. And this basically allows us to verify that the content in that payload and the header has not been tampered with by third parties, that somebody tried to change something in that payload. For example, they intercepted your access token and gave themselves access to your API if they don't have access anyway. And we do this by taking the header and the payload. Depending on the algorithm, you might base64 encode it and run this through the algorithm that's been mentioned in the header. And if you take HMAC SHA-256, that's actually a keyed hashing algorithm. So it relies on a secret key to create the signature and to verify the signature. So you're going to add a secret. But if you, for example, take the RSA SHA-256, that's an algorithm that uses a private and public key pair to do the generation and the validation of the signature. So instead of the secret, we're going to use your private key to create a signature. And then later on, we're going to use a public key to validate a signature if you want to validate the token itself. So JSON Web Tokens can be verified because they always contain that third part, the signature, which is based on the header and the payload of that token itself. Again, I just mentioned this, if you want to validate a signature, if you have HMAC SHA-256, for example, you might use the same secret you used to create a signature. While if you have an asymmetrical algorithm like RSA SHA-256, you use a public key to validate while you use a private key to create a signature. It's just how these algorithms work. But you can always validate the signatures because a public key in this instance is public data. So if we take an example, we have two JSON objects, a header, a payload. And then lastly, we have a secret because we're going to create it based on a secret. We take the base64 of this, we take the base64 of this, and we sign it with secrets. And lastly, we get a JSON Web Token, header, payload, and signature. Now, if we were to copy this and go to JWT.io, which is a website that we've created, which will help you decode JSON Web Tokens if you're working with JSON Web Tokens, and paste it in there. I made a mistake by clicking twice on my payload base64 encoding, but if I would have done it correctly, you would have seen the header, the payload, and if I type in secret here, it would be a valid signature as well. So let's just skip this example because I made a mistake by being too fast and clicking twice on base64 encode in the slides here. But let's look at some real world examples. An access token, we've seen before that we have multiple types of tokens, an access token, an ID token. An access token in the form of an JSON Web Token might look something like this, where the payload would contain information that's useful to an API who is issued by the issuer, which is going to be, in this instance, Auth0, my authorization server. It's going to be about the subject, about that user ID, and it's going to be issued to the certain audience. The audience is usually your API. So this is going to usually contain your API URL. It's issued at this timestamp, and it will expire at the other timestamp. And for example, things like the scopes are also mentioned in the payload of an access token, or often mentioned in these payloads. Well, if we look at an ID token, which is issued when you authenticate a user, it will contain things that are related to a user identity, nickname, name, maybe even a picture, and again, the expiry date and the issue date as well. So JSON Web Tokens are part of the Jose specification. And if you've never heard about Jose before, that's perfectly fine. A lot of people just stick to JSON Web Tokens because it's the most used part of the Jose specification, but it specifies a lot of JW somethings. And it stands for JSON Object Signing and Encryption. And like I said, it specifies a lot of JW somethings, JSON Web Tokens, but also, for example, JSON Web Keys, JSON Web Signatures, and JSON Web Encryption. I'm not going to go deeper into all of them because I would be speaking for another 2 hours, but let's take the JSON Web Keys for a second here, because we've seen that for certain algorithms, we need the public key to validate a signature. A JSON Web Key is a convenient way to share public keys over the internet as JSON as well. So if we take a JSON Web Key, this can be, for example, this. We can use all of the data in here to validate a signature that's been issued by the private key corresponding to this public key in here. And this contains a lot of things like the algorithm, but also the public exponent and the modulus, which are being used in a public key. And if you are using an OpenID server or authorization server, they are often just publicly available at the /.wellknown/OpenID configuration. If you click on it, you'll end up on a page like this, which gives you a lot of more information. But one of the things you can find on here is a JWTs URI link. If you click on it, if you use Auth0, but any other OpenID Connect compliant server will probably also expose these. You see all the public keys that you can use to validate JSON Web Tokens issued by my Auth0 tenant. These are public keys, so they're perfectly fine to be publicly available. You can only validate signatures with these. You cannot create signatures because you would need access to my private keys, which obviously are not going to be shared online. All right, so let's make a little comparison. The header, well, on the left, we have the header of a JSON Web Token, which tells us I'm a JSON Web Token, and the algorithm that's being used for my signature is HS256. And on the right, you have the front of my Belgian passport. I'm from the Kingdom of Belgium, which is part of the European Union, and it says passport, and it says in four languages, because in Belgium, we like to think that we like to make things a bit more difficult. But it's kind of the same thing. The front of your passport tells you what it is, while the header of a JSON Web Token also tells you what it is. It's a JSON Web Token, and it tells you which algorithm you're going to use to validate the signature. Well, if you open this passport, you'll see that it has my name, my picture, my surname, an expiry date, things like that. And that's kind of the same thing for the payload. Now, depending on the use case of your JSON Web Token, an ID token might have some information about the identity of a user. An access token might have some information that's relatable to an API that gives you access to an API or certain parts of an API. But it's the same thing. It's a bit more data about the entity that this passport or this token has been granted to. And of course, most modern passports have some certain measurements in place to ensure that they're not forged, that they're real valid passports, something like a fingerprint or some holograph or something. And the signature of a JSON Web Token is exactly the same thing. It allows you to validate the payload and the header of a JSON Web Token. So a JSON Web Token, you could see it a bit as a passport if you want to. So let's see it in action. We're not going to see it in action because I think most of us know how to use an access token, for example, at an API. But if you want to know more about JSON Web Tokens, that's JWT.io, which I showed briefly earlier, which contains a debugger, which lets you visualize all the contents of a JSON Web Token, and also contains a list of libraries that help you deal with them in a bunch of languages and also a bit more of information. So if you really want to know all of the dirty secrets about JSON Web Tokens, we also have an ebook which you can read. It's quite a few pages, I think over 300 if I'm not mistaken, but it tells you every little detail about JSON Web Tokens if you're interested in that. But let's move on to token-based authentication, because we've seen the traditional authentication, we've seen what a token is and what a JSON Web Token is, and by now we should have at least a basic understanding of what a JSON Web Token is. It contains, or it can contain an expiry date and certain data inside of it, and we can use it as an access token. So let's do that with a token-based authentication flow. The same scenario, the user, the browser, and the API or backend, and the user is going to request a page until the user requests some data that is protected. The user is going to enter the credentials, username and password. We're going to send this to our API, and if it's all okay, we're going to send back an access token. In the first example, we send back a token. In this example, we send back an access token, which we can then use to access our API with this access token. We're going to store this in memory or somewhere else in the browser. We'll see that in a second. And for each subsequent request to a protected resource of this API, we're going to attach this access token as a header to each request. And if that access token is still valid, we get our data and we can show it to the user. And this is done by OAuth. And if you look up what OAuth really is, it's a protocol that allows a user to grant limited access to their resources on one side to another side without having to expose their credentials. So it's a framework to grant limited access to their resources. For example, if you want to import Gmail contacts into your application, you're going to ask some data from a third party. That's what OAuth is designed to do. But if we would like to do some authentication or first party, we might have to work with OpenID Connect, which is built on top of OAuth 2.0. And OpenID Connect was created as an identity layer for OAuth 2.0. That's the basic gist of it. It was created to add that identity layer to OAuth because OAuth has been used and so successfully on the internet for quite a while. So for example, if you want to log in with Google, that's going to be OpenID Connect because we're dealing with identities now instead of just requesting access to a third-party service. So let's break it down and make it a little bit more complex. Same scenario, user browser, but instead of just having one API, which has protected endpoints, we also have an authorization server. This could be Auth0, this could be something else, doesn't really matter, but that handles all the authentication, authorization, and the identity of users. So if we want to get an access token to access this API, we're going to send our credentials to the authorization server. If they match, it will pass along the access token, which we can then use to get some data from the API. But most of the time, it will not only send back an access token, it might also send back an ID token, which you can use in your single page application to show, for example, your username or an avatar. It gives you a bit more information about the person that authenticated. And in some cases, it might also return a refresh token. And like I said, we can then use that access token to access our API and get the data back if it's a valid access token. Well, this is a very simple example, and this uses the OAuth implicit flow, which is still to date the most commonly used flow for single page applications. But the IETF, the Internet Engineering Task Force, has issued a warning for the implicit flow with single-page applications because there are a few weak points in this flow. And these weak points are not new. Most of the implicit flow implementations all around on the internet have mitigated most of them, but they have issued a statement where they don't recommend the implicit flow for single-page applications anymore, but recommend the PXE flow, which we'll see in a second. And some of these weak points are insufficient redirect URI validation, credential leakage by referral header, browser history, and token injection. But like I said, most people who use the implicit flow still today are also mitigating most of these risks. And you can, for example, mitigate the insufficient redirect URI validation by enforcing a strict match between your redirect URI requested and the previously registered one for your client. So if you want to do a redirect with Auth0, you have to tell us which of these URIs are okay to redirect to. And if you try to redirect to another URI, we will not do this because you have to explicitly configure them in Auth0. Credential leakage by referral header. You can set a header with a referral policy to mitigate that risk. Browser history, if you use a forum post response mode instead of a redirect, or so instead of query parameters, you can also mitigate that risk, even though it's not always possible with single-page applications. It gets a bit more tricky. And because of these risks, the IETF, the Internet Engineering Task Force, has published a new best practices document in which they recommend to use the authorization code with proof key for code exchange flow. So we had the implicit flow before. Now we have this very long name, authorization code with proof key for code exchange, often abbreviated as PXE, the PXE flow. So how does that PXE flow work? It's a bit more complicated. Same scenario, the user wants to log in, so it's going to send their credentials to the authorization server, but it's not only going to redirect to the authorization server so the user can enter their credential. Your application is also going to create a code challenge, which is a cryptographically secure random number, let's say. And we're going to send this to your authorization server, which will store this for a bit. The authorization server will not immediately give you an access token and the other tokens, but it will first give you a code. And the code is going to be remembered by your application for a while. And it's going to take that code together with a code verifier and send that back to your authorization server. And that code verifier is basically a hash of the code challenge we created in the first step. So we can verify that it's the same party that's completing the flow. So we're going to take that code we got from the authorization server together with the code verifier, which is based on the challenge we created initially, and send that to your authorization server. It's going to do some compare work. But if it all matches, it's going to give you your access token, your ID token, and sometimes also your refresh token. So there's a few more steps, but it makes this flow a bit more secure, especially with single-page applications who run on the front end and cannot really contain any secrets because it's all JavaScript code, all front-end code. And then again, you can use your access token to access your API. So let's see this in action in a different way. This is a website I am building, but we have the same scenario. The user clicks on a login link. So the user goes to the application, clicks on the link. The next step will be that the application, the single page application, will create a code verifier and a code challenge. While the code challenge is a cryptographically secure random value, and the code verifier is a hash of that value. The application will then do a redirect to your authorization server, Auth0 in this instance. And if I log into Auth0 with my email address, I have to give access to it because we're doing OAuth and you have to authorize the application. But once you do this, you only have to do this on the first step. We see a few things have happened. My Auth0 tenant, my authorization server, has redirected back to my application. The user has given some consent, and then it will authenticate back and give you the authorization code. Now, this authorization code at this stage is still useless. Next step is going to be that your authorization, your single page application, your front end is going to take that code verifier, which we created in the second step here above, which is related. It's based on the code challenge, which you already sent to your authorization server. It's going to take that together with the code we got back from this request in step 3 and send it all back. So if we look at the data, we're doing the authorization code grant type for this client ID with the code verifier, which we saw on top, and we also pass along the code, which is the code we got back from the authorization server. And once we do this, we do get our authorization server is going to verify the code and see if it's based on the same challenge, and if it all checks out, we get our access token, our ID token, and sometimes also your refresh token. So it's a bit more back and forth, but it's a bit more secure as well. So that's the PXE flow that's been recommended by the IETF to use with single page applications. A quick note about access tokens as JSON Web Tokens. OAuth and OpenID Connect do not specify which format an access token should be. So they don't have to be JSON Web Tokens. They can be anything. They can also be an opaque token. That's, for example, an ID of a database, which contains more information about the access token. But they can also be JSON Web Tokens. And there is an IET draft, which has been finalized by now to standardize this. And it's started by my colleague, Vittorio. But it basically specifies how an access token in the form of a JSON Web Token should be. And if you look inside of it, there's nothing new. It tells us the scope, the client ID, expiry date, and so forth. So it's just a standard JSON Web Token, but all the claims have been standardized in this specification. So if you want to use an access token that is a JSON Web Token, know that there is a specification to standardize these tokens. ID tokens are always going to be JSON Web Tokens per the OpenID Connect spec. That's how they're specified. And lastly, a note about refresh tokens and single page applications. Using refresh tokens in the front end with a single page application, that is, should be avoided unless a system of refresh token rotation or sender constraint is in place. So if you don't have one of these two systems, refresh token rotation or a sender constraint, you should not be using refresh tokens with single page applications. That's a warning. So if we don't have refresh tokens, you might not have a persistent session, which means that once your access token expires, the user has to log in, which is annoying. And we don't even recommend to save access tokens somewhere persistently in a browser if you don't have the system in place. So how do we get persistent sessions? Well, the first solution is easy. You just save your access token and refresh token in local storage if you have refresh token rotation in place or your authorization server has this in place. But like I said, it's not advised if you don't have refresh token rotation and automatic reuse detection in place. And this is something we do at Auth0. We refresh tokens. Each time you use a refresh token, you get a new one back. So it's only valid for one time. And we also detect if somebody tries to use an access token or any token that's related to a refresh token that has expired. If somebody tries to use one of those, we just expire all of the tokens that are issued to that user. So as soon as somebody tries to misuse one of the access tokens or refresh tokens, we detect that and we cancel all of them. But if you don't have this in place, you might be able to save an access token in a HTTP-only cookie. An HTTP-only cookie cannot be read by the JavaScript, so the content of that is only going to be available to the cookie and to the backend. But then again, you're working with cookies. And like we saw in the beginning, cookies don't work with cross-origin requests. So if your backend and your frontend run from a different origin, you might run into coarse problems. And lastly, you can do something that is called silent token requests through an iframe. And it's a very complicated flow, but basically you're going to save a cookie issued by your authorization server. And you're going to send that through an iframe to your authorization server, which will then send your access token. So that's the first thing you do when you bootstrap your single page application. You open an iframe, do a request to your authorization server, attach a third-party cookie, and get your tokens and post those tokens from that iframe to your application. And we still do this if you don't enable refresh token rotation at Auth0. But the downside is that it relies on third-party cookies, which are blocked by some browsers. If you're using Safari, for example, or Brave, they block third-party cookies, so this will not work properly. So does token-based authentication, does it solve CORS? And usually I can see some hands go up when I ask this question. I cannot see this at the moment. But in a way it does, because you can, in theory, pass along tokens or use them, not in theory, you can use access tokens as JSON Web Tokens across origins. They're not issued to an origin, they're issued to an instance, to somebody or something. And as long as you know how to validate those tokens, as long as you know how to validate the payload, the expiry date, and as long as you know how to validate the signature, you're good to go. Does this approach solve for flow? In theory, you could pass along access tokens from one service to the other. In practice, you're going to exchange them with the token endpoint of your authorization server. But in theory, you could just pass them along as is, which is not recommended, but you could do it. The best way is to exchange them before you send them off to another service. And does this approach solve for keeping state? Well, because the access token has all of the information inside of it, you don't need to keep a separate database with all of the information related to that access token or to that token. If you don't want to, you can just put it all inside of the payload of that token and be good. Now, there is a caveat here as well, and that's if you want to invalidate JSON Web Tokens that are technically still valid because their signature is still valid, their expiry date is still in the future. It's very hard to invalidate these, or you cannot invalidate these unless you keep a deny list or a list of tokens that you don't want to accept anymore. So if you want to do that, you're still keeping a database, you're still keeping some state, but the actual token state is going to be inside of the token. So you're already getting rid of a bunch of state, which doesn't have to be in your database anymore. So let's summarize. Using session cookies is hard with single page application. We've seen this: course, flow, state, all of these things. A JSON Web Token consists out of three parts: the header, which tells us a bit more about the token itself; the payload, which contains the actual payload, the actual data of the token, depending on which token it is. An access token will contain some more information about an API. An ID token will contain some more information about the identity of a user. And it contains also a signature, which lets us validate that payload and that header. And lastly, tokens offer a bit more flexibility when working with single page applications because they're not issued to an origin like a cookie. So it's a bit more easier to work with them with single page applications. If you want to know more, JSONWebToken.io is always going to be there. We also have a bunch of nice blog articles on our blog, auth0.com/blog, related to JSON Web Tokens and tokens in general. For example, there's a link to how we implemented and why we implemented refresh token rotation on our blog. These slides, or a version of these slides, because these slides are always changing, is always going to be at jwt.sambiego.tech. And that being said, thank you very much.